Everybody, in this electrical troubleshooting series, we're going to be taking a look at the turn signal system on this Honda CB350. The same architecture system is used on the majority of the old Hondas from the 60s and 70s. There were some changes in the mid-70s with the front turn signals also having some running lights. We're going to take a look at all the different components in the system, test them out, explain how they're all connected together, and hook it all up and show you how it works. Let's get into the logic of how this system is constructed. It's pretty much the same amongst all Hondas built from the mid-60s through the mid-70s. We have 4 turn signals. Really, we have two turn signals in pairs. We have a left side and a right side. Regardless of the signal, they all start at ground. Make sure you check out our video on understanding ground circuit before you dive into this. And also, each turn signal have different grounding arrangements and how they connect to ground. We'll go into those details a bit later. All we have to know is they always start at ground, regardless of front or rear. Really, we got to think about them as left and right. So, starting at ground, depending on what side they are, they're joined together, left side, right side. They run through the harness up to our turn signal switch here. Our turn signal switch divides it into left and right. Through the turn signal switch, out to our flasher relay. This bike happens to have our aftermarket electronic relay, but it could have the old style relay in it. Through the relay, back to our solid black wire, which is our 12 volt positive side of the circuit. Check out our video on 12 volt positive if you haven't seen that. All the way back to the positive side of the battery. I know that seemed real simple because, well, that really is the path. There just happens to be multiple lights that all share a common circuit. So we're going to dive deeper into each of those here in a minute. While the logic of the circuit always starts with ground and works its way to the positive side of the battery, in this instance of doing the diagnostic of the turn signal system, we're going to approach it backwards. We're going to start with the areas that have the fewest components, which is going to be a turn signal relay and the switch, and then we're going to work our way out to the individual turn signals. So we're going to start like this, and then go to this, and then go to this, versus the opposite where we be merging in. A little bit backwards in the logic, but it makes us eliminate some larger variables more quickly. And as always, the first thing I'm going to test is my test light to make sure my test light is good and that my battery is good. So connect to ground, positive side of the battery, and my test light is good. Always test your test light. All right. Next thing I'm going to test is going to be the turn signal connection from the turn signal relay to the positive side of the battery. So I'm actually going to take the turn signal relay out and we're going to test it later. It's actually going to be the very last thing we test. A lot of people want to test it first. It's going to be the last thing we get to. The reason that the turn signal doesn't really matter in the circuit, because all it is a very simple on-off switch. We can test that the lights and signals are getting power without it having to flicker on and off. Additionally, when we have an electronic one like this one, they tend to get cooked easily, especially if we short something out. So I don't want to fry this turn signal relay until we know that everything else is working. So I'm going to take it out of the equation as a variable, and we'll test it later. So the first thing I want to test is these are our 2 wires out of our turn signal indicator. Solid black wire, which we've talked about in our 12 volt positive video, obviously goes to the key switch, back to the positive side of the battery. Let's make sure we're getting continuity and power through that first. And our gray wire is what goes up to the actual left-right turn signal switch on the handlebars. But let's check to see if we're getting power from here back to the positive side of the battery. I'll go ahead and connect my test light to ground. I'm going to take my test light, put it into the terminal there and turn the key on, and we should get the test light to kick on. So that means from here, back through the key switch, the positive side of the battery, we have 12 volt positive power. Good. Now, since I've taken the flash relay out of the circuit, what I'm going to do in the meantime to bypass it is I'm actually going to jump our black and gray wire together. That means I should have 12 volt positive power up through the switch and out to the wires that go to each turn signal. And to do that, I'm going to use one of my jumper wires here. Make sure I get in there nice and clean, like that. And I also want to make sure that I do not let my other side of the jumper here touch anything that's ground on the bike. You know, keep that isolated, because if this wire touches ground, we'll short out. But I also have the key switch turned off, so we're good. And we're going to move up to the headlight bucket and take a look in there. We are now inside the headlight bucket, and we're going to test the turn signal switch now. I'm going to point out, here's our gray wire, and this is the only gray wire that's in this bike. So this connector here is the connector from the flasher, where we just checked, all the way into this connection going into the handlebar switch. Remember, we put a jumper to bypass the flasher. I'm going to connect my test light to ground. Of course, we know that any solid green wire is ground. I'm going to turn on my key switch very carefully, not to disturb that jumper. And I'm going to check for power at that gray wire. Test light's on, so that means I have power from here all the way back to the positive side of the battery. This gray wire then runs into the turn signal switch and comes out either as a light blue or orange wire, depending on what side the turn signal switch is switched to. Here's an easy way to remember this. Light blue is right blue, right? The light blue is the right side and the orange is the left. So what I'm going to do, I'm going to take my test light and touch it to here. We'll go over to my turn signal up top here, and let's go to the right-hand side and see the test light kicks on. Okay, that means we have that side of the switch is working. Let's go to the other side of the switch. I'm gonna take that off of there, touch it to here, flip the switch the other direction, and that's it. So that's left, and then go to the middle, it's off, and either side is illuminated. So that says our switch is working properly. So we know that both the left and right side wires here through the switch are good. The next place this goes is into this bundle. This wire is going to tap into this group here. And what we have is, I'll tell you what the other three wires are. One of them goes to the actual front turn signal, 12 volt positive, so that should be this one right here. One of them goes to the gauge indicator up here. And the last one goes all the way back to the rear of the bike to the rear turn signal. I'm going to plug this one in. So there, click, and that is that bundle. We have the same thing for the left side with the orange. Come to this side here, it's a little bit harder to see. Same thing though, we have a four bundle connector here, 1, 2, 3, and then our fourth one is our one out of our switch. Let's see if we can plug that in nice and clean. Right there, and I unplugged those to test that the signal indicator out. All right, go ahead and turn my key switch back on. Remember, I always turn it off anytime I make a move. And test light the light blue side. Let's go to the right. So not only is my test light on, but I went ahead and got my front turn signal light. So it says that that side's good all the way to the front into the gauge cluster there. And actually, I can see that my rear one is working, but we're going to go to the back and show you how to troubleshoot that in just a minute. We have our rear light is on. There. Turn that one off. Let's do the same thing on the left side. I went ahead and put my test light over on the orange connector. Turn signal, test light's on, power is good. I have power going to that turn signal as well. And actually same thing all the way to the back of the bike. A point of confusion for a lot of folks in dealing with the turn signals is the actual flasher indicator bulb inside the gauge cluster. The majority of these bikes use a single incandescent bulb to trigger both left and right side turn signals. Later on, Honda went to like an individual bulb for the left and right side, like on some later 750s and bikes in the late 70s, but like on this 350, it's one bulb. And we're gonna actually test that bulb by itself. I'm not gonna get into the whole logic of the circuit. We have another video that explains that in detail because it pulls its ground circuit from the opposite side that's illuminated. So if the right side is flashing, or I should say left side is flashing, that bulb is pulling its ground through the right side. It's kind of a goofy system, but it works. But let's just unplug it and show you how to test that bulb and part of the circuit to make sure it works. I'm back at my light blue and orange clusters here for our turn signal system. And I'm going to unplug the wires that go towards this. And the way I know it's the wires for the turn signal indicator is I found a group of wires here that has not only a blue wire, that's our high beam, a light green wire with a red stripe, which is going to be our neutral light, and then here's going to be our turn signal indicator on that side going in, and then here's another one on that side. And you can see that both of these wires come into a common housing here, sheath, which run up to the indicator bulb right here. Keep going. So the way I'm going to test this is going to be a little bit different than how we've been testing with the test light. I know for those of we've been following along, and we know a 12 volt positive, I happen to have a black 12 volt positive connector right here in my headlight bucket. So what I'm going to do is I'm going to take one side of the turn signal indicator bulb, I'm going to plug it into the positive. I'm going to go ahead and double check to make sure I do have a 12 volt positive there at my black wire. So I'm going to connect to ground, which is always a good test right here. Test light's on, that means we have 12 volt positive power there. And I'm just going to touch this to my ground connection here and see if my light turns on up top. And sure enough, it does. So the light turns on, it says, well, first of all, the bulb is good, but also the socket's good, and the wiring that goes from the socket into the bucket is good. Now, if your bulb's not turning on, that's the indicator to actually crack inside the gauge or the gauge cluster to figure out, do I have a bad bulb? Do I have a dirty socket? Something like that, where that's where the problem's gonna lie right there, because we've isolated that light bulb and socket from the rest of the turn signal system there. At this point, we're going to go from, remember we're testing it as a single unit, those single things like the turn signal switch, split into twos, left and right, and now we're going to split into the four again, meaning each turn signal independently of one another. So we're going to show you how to test the front ones, we'll go to the back, we'll test the back ones, and hopefully you'll figure out your turn signal problem. You know, in testing the front two signals, they're basically identical. You know, they're just mirrors of each other, or they're symmetrical. So in this case, I'm going to just do this right-hand signal that's closest to me, but the same exact process would be used to diagnose this left-hand front signal. We said that light blue is right blue, so we're going to go to our 4-pin connector here that we checked just a minute ago. And I have a black wire with a light blue sleeve on it. I'm going to unplug that right here. And if I kind of snake it out from the bird's nest here, well, you can see a little better. This wire is going to be our 12 volt positive wire for this turn signal here. So now that we have this unplugged, the first thing I'm going to test is, do I have a good ground to this actual turn signal here? Now basically it's supposed to ground through the body, through the stem, through the ear here, to the bolt, to this ground wire here, the bolt with our dark green wire. Let's test the ground with our test light. So what I'm gonna do with my test light is I'm gonna connect to a 12 volt positive source. And in this cluster here, I happen to have a 12 volt positive bundle here that's a solid black wire. Again, always refer to our 12 volt positive circuit video for more explanation on that. But I know when I put the key on, that should illuminate. All right, let's test the ground going to the actual socket here. I'm just gonna hook to this bolt that's here on top of the turn signal, like that. And let's go to here. Left my key on, and of course I have good ground connection here. Hopefully I have good ground connection inside the socket here. If I'm still having problems after I check this ground and the 12 volt positive side, the issue might be actually in the bulb socket. You might have to look at there, but I've isolated this from the rest of the circuit. And now I'm just gonna take my 12 volt positive wire, I'm gonna touch it to that black solid in there, and the light should kick on. And it does. So that means that light is okay. If you're still having trouble, instead it could be a bulb, it could be instead a bad socket in there, you'd have to get into and check out. But we isolated this one from the rest of the circuit. The same exact process can be done for the opposite side. It's gonna be a solid black wire with an orange tube instead of a light blue tube. We are at the rear of the bike now, and we have this little cluster of wires that comes out that goes into the tail light and also into the turn signals, and we're going to check, do we have 12 volt positive power at our respective light blue and orange connections, and these run all the way up to the headlight bucket where those big bundles are. And I'm going to unplug the light on that side and that side, so I've isolated my turn signal lights. And I'll take my test light, hook to ground, turn on my key, and let's see, orange should be left. Sure enough, test light kicks on orange side. So that says I have good, circuit all the way from here back to the positive side of the battery. Let's come to the blue side, check it over here. Same thing, light blue is right, it is. So that means we are good from this point all the way back to the positive side of the battery. I'm going to leave those unhooked, and we're going to talk about the actual turn signals themselves in this configuration. So on the rear turn signals, there's a couple different configurations. This is a later one where the actual stem, this is considered ground, but then from the stem over to the wiring harness, there's an extra ground wire that's connected. In fact, see, I see this extra wire here. It goes into our green bundle here, which we know is ground, and actually it has a green sleeve on it, so that's connected to ground. And I have another wire here, that's my 12 volt positive wire. This one's showing a orange sleeve on it. That should go to the 12 volt positive side of the bulb. What I'm going to do with this one is I'm going to connect this one just directly to the 12 volt side of the battery and see if I have a jumper here going to the 12 volt positive side of the battery. And I should have my light just kick on. All is good. Look at that. Clip there. Light kicks on, so that I've isolated the light from the rest of the circuit. Light kicks on, it's good. Again, if you're having problems with the light illuminating, the problem could be the bulb is the most obvious thing, or the socket. Same thing on the opposite side here. Same deal. It's connected to ground, and sure enough, that side illuminates as well. Again, each of these are the exact same setup, but if they're not lighting independently, if you test them, that means you have a problem with something in this part of the circuit, whether it's a ground connection here, bulb, socket, something like that is your problem, not the rest of the wiring in the bike. The very last thing we're going to test was the first thing we removed from the equation, which is the actually flasher relay. And I have in my hands here the two types of flasher relays you're going to find on the bikes. This silver one is your more typical old style thermal flasher, which is current based. This really only works with incandescent bulbs and mostly the factory style turn signals with an incandescent bulb in it. Over here, this is our low threshold flasher relay, or the one we'd use with the LEDs. We're going to test them both, show you how they work. And in this case, I'm going to be using this single turn signal indicator as my test light, basically, because it has an incandescent bulb in it, and it's going to pull enough current to trigger both of these. Test light with the LED in it doesn't have enough load to trigger this, because this is current based and it has to have enough pull running through it to warm up and trigger. So I know that my turn signal is already connected to ground, and this would have been my wire going to my 12-volt positive. Let's do the old style thermal connect first. So I'm just going to take my flasher relay. I'm going to connect it to the B wire here, the B terminal going to the battery. I'm going to go to the positive side of the battery, and then I'm going to take my wire here and just touch it to the terminal and see what flashes. I actually feel it clicking in my hand, so obviously that works. And it took a second for it to illuminate because this had to warm up. All right, we're going to reverse it, and we'll go from there. It should work either way. Sometimes on these old mechanical ones, they can work either way. Sometimes they only work one direction. It really depends who makes it. So this time I'm going to hook the 12-volt positive to the L connection, and let's touch this one to the B and let's see if it works. Yeah, sure enough, this one works either direction. Same exercise with the electronic flasher. I do know that these are directional, so well, let's try that. Terminal there, the one. Let's touch this there. Flashes, no worries. But if I flip it around the other way, it should just turn on without flashing. Yeah. So if it turns on, doesn't flash, typically you have it hooked up backwards in your system. This concludes the turn signal diagnostic electrically on this Honda 350. Again, the same architecture is used on many other Hondas built from the late 60s to the mid 70s. And our approach of going from singular into double into fours made it a lot easier to try to find what the issues are. Grounds are very important as far as how the lights are connected, and of course, making sure all your terminal connections are in good shape. This bike seems to be working now properly, so we can kick that on. And sure enough, our left side signals are working and our turn signal indicator is working as well. Same goes for the right side. This is Brendan with Common Motor, common-motor.com on the internet. Make sure you follow us on Instagram and Facebook. Subscribe to our newsletter via our website, and of course, subscribe to this YouTube channel down below. Make sure you ring the bell for future notifications, and we'll see you next time.